When simplifying expressions, many math students are taught the acronym PEMDAS, which stands for parentheses, exponents, multiplication and division, and additions and subtractions. And they're taught to do parentheses first, then exponents, then any multiplications and divisions, and then any additions and subtractions. So we would go from left to right in the acronym. However, when we are solving equations, we want to do exactly the reverse. We want to undo operations, not do them, in order to get a variable alone. So interestingly, the order that we have to undo things in is in reverse PEMDAS order, with additions and subtractions being undone first, then multiplications and divisions, then exponents, and finally parentheses. I'm going to start off with a few one-step problems here. Now the one-step problems don't require PEMDAS in reverse because there's just one thing to do. But when we go to the two-step problems, we'll see how that works. First, let's try just a few one-steppers here. I'll get x alone by subtracting 8 on both sides. Here, I need to undo that -1. Now, the way I'll undo it, though, because his sign is negative, I have to undo him with an addition. Okay, that's going to leave us with x equals -12. Let me box my answers here so that it's clear. Okay, what's the inverse of subtraction? Addition. Now you can just plug that into calculator if you need to. Just type in -14 plus 6 on calculator here, and that'll give you the answer. Okay, now we've got division. X divided by 7 equals -3, but our x over 7 is also negative. So how do we get rid of something like that? Well, it's division. So we want to do the inverse of division, which would be multiplication. Okay, so the change that I'm going to make this time, I'm going to actually write it on the line of the equation, the original equation itself. Sometimes it's easier to do it there than down below, especially when you're having to multiply things. All right, so what do I want to multiply by? 7, okay, on both sides. But notice that there's a negative there. If I just multiply by 7, then what I'm going to get down below would be -x equals -21. But I don't really want to know what -x is. I want to know what x is. So what I'm going to do is I'm going to multiply by a -7 here on both sides. What that'll do is it will cancel not just the 7's here, but the negatives too, because a negative times a negative makes a positive. So I'll have x alone, and I have to do -3 times -7, which is +21, and that gets me to the final answer. So that brings me to, what do we do if we have a multiplication by a fraction? Now Now we could do a division. We could say down below, divide by negative 2/3. We could do that on both sides. But there's a better way to write it. If you're dividing by a fraction, there is this trick which says, for example, I'll write it on the side here, x divided by a over b is the same as x times b over a. We're allowed to change the division sign into a multiplication and then also flip the fraction. Those two changes end up canceling out so that the result you get for the top would be the same as the bottom here. And that's what I want to use on this problem. Instead of writing my division down below, I'm going to multiply my fraction here by what is called the reciprocal, 3 over 2 on both sides. Now, since there's a negative there, I want to take the negative with me as well. That'll cause the negatives to cancel, and what will happen, as you can see, is that the 3 above cancels with the 3 below, the 2 below cancels with the 2 above, and even the negatives cancel. Everything cancels, and it leaves just x. Great algebra solving technique. Now, when we have negative 7 alone here, you may recall from basic math that that is the same as negative 7 over 1. And when we're multiplying fractions, we want to multiply the numerator times numerator and denominator times denominator to get a final result of 21 over 2. And that'll be our final answer. Alright, so here I have x over 5 equals 1 over 6. I'm going to undo the division by multiplication on both sides. As we can see, the 5 will cancel here, but I have a 5 on the right, which is the same as 5 over 1. Multiply the tops together and the bottoms together. Final answer, 5/6. Okay, those are one-step problems. Now let's try some two-step problems. But remember, we have to undo the things that are happening to x in reverse PEMDAS order. So first of all, what's happening to x? Well, there's a multiplication by a negative 5, and there's also an addition of 1. Which should we undo first? Well, according to PEMDAS in reverse, additions and subtractions get undone first. So, I want to subtract that 1 first from both sides. That'll leave me with a negative 5x on the left and a negative 5 on the right. Now it's transformed into a one-step problem. The next thing to do would be to divide, not just by 5, but by negative 5 too, because we want those positives, the two negatives to become positive. So that'll give us a final answer of x equals 1. Now we can check our answer. Negative 5 times x plus 1 equals negative 4. plug in our 1. You get negative 5 plus 1 equals negative 4. Negative 4 equals negative 4. It checks. Great. Okay, let's undo the addition first. And this is a problem that actually gives people a lot of trouble. What do you do when you have 2 minus 2 on a side where they would cancel to nothing? A lot of times people forget about the equals sign at that point and they're not sure where to go after that. But the fact is that equals sign cannot disappear. I mean, it's not there in this line where we had made the change, but that line is reserved for the change. Okay? You don't have to have an equals in that line, but you do have to have an equals in the next line. And what does it equal? 0, because 2 minus 2 makes 0. The last thing to do would be to get x alone by dividing and 0 over 4 does have an answer. It's 0. Now let's check it. 4 times x plus 2 equals 2. We believe that x is 0. Does it check? Yes, it does. Okay. Here there's a subtraction. But this is a positive 4. To get rid of that positive 4, we have to do the inverse of positive here, which is negative. The opposite. It'll leave us with negative 2x equals negative 10. Divide by our negative 2. X equals 5. Okay. Let's take the negative with the 3. Alright, and in this one we have a negative 10 all by itself there on the left. Let's undo that by adding 10. It's got to be the opposite. Now they cancel. The negative sign belongs with the 2, so we keep it with the 2. X equals 4.